Welcome to Networking and Health Information Exchange, Network Media and Hardware Communication Devices. This is Lecture A. The objective for this lecture is to select appropriate hardware devices such as routers, switches, and access points to facilitate networking and data exchange, taking into account access and regulatory requirements.
Slide 3. We know we need a NIC in each node and media to connect the nodes. Now what do we connect the node to? We can use a hub, switch, router, wireless access point, WAP, or modem. These devices will allow nodes to talk to other nodes on a network. Slide 4. Hubs contain multiple ports to connect multiple devices. They are not used a lot in modern networks, but you may still encounter them. They are cheaper than switches and work well for just a few nodes. Each node has a connection to a port on the hub. There is a security concern with hubs. If data comes into one port, it goes out to all other active ports. This means that the signal, data, can be received by all devices connected to those ports. By default, a device will not read a packet if it is not addressed to the device. If packet sniffing software, like Wireshark, is installed on that device, and the device is running in promiscuous mode, it will read all the packets that it receives, regardless of the address. If the packet contains unencrypted data, like usernames or passwords, then the user of that device now has that information. Another problem with hubs is that bandwidth is equally shared among all active ports. If the bandwidth coming into the hub is 10 megabits per second, and there are 5 active ports, then each port has access to 2 megabits per second. The ports are all part of one collision domain, which means that all devices connected to those ports must compete with each other to have access to the network. Slide 5. With switches, each device has its own connection to a port on the switch. Each port is a collision domain, so a switch with 4 active ports would have 4 collision domains. If there is 10 megabits per second coming into the switch, then each port has 10 megabits per second. Switches have a switching, or MAC table, which means that a table is created that associates the MAC address of the device connected to the port with the port number. If a packet is destined for a particular device, or MAC, then that packet will only be sent to the port associated with that MAC. This is a more secure form of data transmission. It is not susceptible to the same type of packet sniffing issue we had with hubs. Switches operate at Layer 2 data link of the OSI model. Slide 6. There are more sophisticated switches that can operate at other layers in addition to Layer 2. Layer 3 switches can interpret Layer 3 network information. Layer 4 switches can interpret Layer 4 transport information. Slide 7. Routers are multi-port connectivity devices that connect different types of networks, LANs, WANs, different transmission speeds, media, and protocols to each other. Routers operate at the network layer, Layer 3 of the OSI model. They move or route packets from one network to another. Slide 8. Routers choose the best route for a packet to take to arrive at its destination. There are 2 ways that the router knows what the best path is: static routing and dynamic routing. In static routing, a network administrator programs a router to use a specified path to move data between 2 nodes. In dynamic routing, routers automatically calculate the best path between nodes and accumulate this information in a routing table. Routers share information about the routes with each other. A hop is a term used to describe the movement of data from one router to another. For example, if a packet travels across 3 routers from its source to its destination, it is said to have taken 3 hops. Slide 9. A wireless access point, WAP, is used to provide wireless access to a network. It uses the 802.11x standards. Each WAP has a Service Set Identifier, SSID. Wireless devices use this SSID to make an association with the WAP. Wireless is, by default, an unsecure transmission method. You should take precautions to secure your WAP. This includes setting up wireless encryption standards on your WAP. This requires each wireless device to have a password to authenticate to the WAP. It is also used to encrypt data that is being transmitted between the WAP and the wireless device. This is beyond the scope of this unit. Be aware that unsecured WAPs are a big security risk for your network. Most WAPs in homes are a combination of a switch with multiple ports, a router that moves packets between wired and wireless networks, and a wireless access point that provides access to wireless networks. Slide 10. A small office may use a digital subscriber line, DSL, or cable modem to provide Internet connectivity. A DSL modem is a device used to connect a computer or router to a telephone circuit that has DSL service configured. DSL is provided by your local phone company. The location that wants to have DSL has to be within a certain distance, generally 18,000 wire feet, of the phone company's central office. Slide 11. Using the same method in which you get cable TV, you can now get Internet connectivity. The coaxial cable coming into your house would be connected to the cable modem, and then a twisted pair cable would be used to connect a computer or WAP to the modem. Cable is a shared bandwidth system, so the more people using the system, the less bandwidth each customer receives. In Unit 2, we have discussed transmission basics, network connectivity, types of media, standards for structured cabling, and connectivity devices. Slide 12. This concludes network media and hardware communication devices. We have covered transmission terminology, network media types, and connectivity devices.